Hello everyone, welcome to MK Maths. I am Karthik Manasali. So I have explained three questions, three 5 marks questions in previous video. If you not watched those three questions, check my description. I have mentioned link. Through that link you can watch those three questions. So in this video I am going to explain about the fourth question. So this is very repeatedly asked 5 marks question in the topic functions. So these are the four important questions. Previously I have explained the three questions and this is the fourth question. These four questions are very important. Within these four questions only we can expect one 5 marks question from this topic function in NCERT board. Okay, so in this fourth question there is a extra concept is there, so that is invertible concept. I am going to cover that concept also within this question only. After understanding the concept of invertibility, now we can solve the easily this problem. Okay, so let's start the problem. Let us understand how to solve this problem, okay, with the help of invertible function concept. So this is repeatedly asked 5 marks question. Here the question says, let f is a function from natural numbers to y. Here natural number is a domain, and here capital Y is a codomain. Okay, so natural numbers means we all know it contains 1 2 3 4 5 6 so on. So here capital Y means still we don't know what this capital Y denotes. So in further they have mentioned this what this y denotes. Okay, so this is a function from natural numbers to y. So this is function defined as like this: f of x equals to 4x plus 3. It means if you input x value natural numbers, it is going to calculate 4x plus 3 value which is in codomain y. Okay, so where y indicates, so now they are going to explain about this y. So y is the set which contains y. Small y means it contains elements which is belongs to natural number. So capital Y also contains a natural numbers, but there is a restriction. The restriction is those natural numbers should satisfy this 4x plus 3. Okay, 4x plus 3, what will, after substitution for x values from the domain natural numbers, after substituting the x value here, what the output we get a y value, those are all natural numbers. Those values are present in this capital Y. So if we consider the x value equals to 1, now the y becomes y equals to 4 times of 1 plus 3. 4 times of 1 plus 3 means 7. So y value contains 7 now. So if you put x value equals to 2, then y equals to 4 times of 2 plus 3. 4 times of 2 is nothing but 8. 8 plus 3, 11. So it contains 7, 11. So if you substitute x value 3, it becomes y equals to 4 times of 3 plus 3. 4 times of 3 means 12. 12 plus 3, 15. So this y contains 7, 11, 15, so on. So this type of numbers are present in y. So 7, 11, 15 are all natural numbers, but this set y does not contain 1 2 3 4 5 6. There is no up to 6, there are no numbers here. It starts with 7, there will be no 8, 9, 10, and it again start with 11. There will be no 12, 13, 14, again there is a number 15, like that. Means whichever the numbers satisfies the 4x plus 3, whatever the value we get after solving a 4x plus 3, those values are present in this capital Y. Okay, I hope you understood this codomain y here. So this codomain y contains only the numbers which satisfies this 4x plus 3 after substituting x values here. So what the 4x plus 3 will produce output, so those numbers are present in y here. Okay, so next question will be, show that f is invertible, find the inverse. So this is the question. This is the question they are going to ask for 5 marks. So here we have to show first the f is invertible. We have to show f is invertible and also find the inverse here. Okay, so before to show f is invertible, first we have to understand this, what is this function, invertible function. If we understand the invertible function, then it is easy to solve this problem. Okay, so let's understand the invertible function. So invertible function is easy, we already know about some concept here. So invertible function is nothing but f is 1 1. Here f is 1 1. Here f is 1 1 and onto function. We already know about 1 1 and onto function. I have explained in previous videos. If you not watched those definitions and examples, you can watch, which I have given in description. Okay, so f is a 1 1 and onto function. If f satisfies this both 1 1 and as well as onto, then we can call it as f is a invertible function. So if the function satisfy both 1 1 and onto, then we know f is said to be bijective function. Okay, similarly f can also be said to be invertible function. So what is this new invertible function here means? So let's understand with the example. Okay, so I consider the example here, f of x equals to 2x. Okay, just for example, to understand this invertible function, I have considered f of x equals to 2x. So I have taken a simple example to understand this definition. I have considered simple example, f of x equals to 2x. So f is a function from natural numbers to natural numbers. I have considered f is a function from natural numbers to natural numbers. Okay, so here if f is a function from natural numbers to natural numbers, how it will work, let's understand here. Okay, so if I consider 1 2 3 4 so on, so this is a natural numbers. So if I substitute, this is the function here. Okay, this is the f. If I these are all x values. Okay, these are all x values. Whatever I get in codomain, whatever I get a codomain are all nothing but f of x values. So I hope you understood. These domain elements are all x values. After substitution in x value, we get a output. No, these are all input value. After we get a output value, those are all present in this codomain. We call it as a f of x. So if I substitute 1 here in the place of x, if I substitute 1, 2 into 1, it becomes 2. So 1 maps to 2. 1 maps to 2. So if I substitute 2 here, so 2 becomes 2 here. So 2 times of 2 is 4. So 2 maps to 4. So similarly, if I substitute 3 in the place of x, 3 times double is nothing but here. If you put a x value here, it is going to make it twice. So 2x means it is going to make twice. Whatever number you input, it is going to double it. So if I put 3 means it is going to double, so it becomes 6. So similarly, if I put 4, it is going to 8. So let us take codomain. So to become onto, let us change this codomain part. This only contains even natural numbers. Okay, even natural numbers. Even natural numbers I have considered. Okay, this is codomain part, even natural numbers. So if you observe clearly here, so if you put x value, we are going to get 2. If you put 2 value, you are going to get a 4, because the example we have taken, f of x is nothing but 2x. Double of x, whatever the input we in f of x, it is going to double which is in output. So if you put input as a 1, then it is going to be 2. If you input as a 2, then it is going to be 4. Similarly, they are all doubling of this x. Those are nothing but f of x. So if you observe clearly, this is satisfying 1 1 and onto definition. So 1 1, how it's satisfying 1 1? So if you check for f of x1 equals to f of x2, for 1 1, how we check f of x1 equals to f of x2? F of x1 means 2x1 equals to 2x2. These two get cancelled. So x1 equals to x2. So it means f is 1 1. So it becomes 1 1. So 1 1 is satisfying. If you check for onto here, if you check for onto, how we are going to check for onto? We are going to, this is onto, no? How we are going to check onto? We consider a y in codomain. We make sure that this y is equals to our given f of x. This y equals to 2x. Now we are going to find a x value which is present in domain or not. So x equals to y by 2. Now x becomes the y by 2. If you observe clearly, here y are nothing but a double of x. Y are nothing but a double of x. So if you substitute y values here, it is going to be a which is present in natural numbers, because y is nothing but a 2, y is nothing but a 4, y is nothing but a 6, y is nothing but a 8. Y are all even natural numbers. So if you y value consider even natural numbers will be obviously divisible by 2. It will be, so this x equals to y by 2 will be obviously belongs to natural number. So it becomes onto now. So it becomes onto. So it satisfied both a 1 1 and onto. Then this f is a invertible function. So invertible function is nothing but, so if f is a both 1 1 and onto, then we can create a function in reverse order. We can create a function in reverse order means, so if you double the x, it is you are going to get a codomain values. No, if you divide the codomain, you are going to get a domain values also. So that is the new function here. So I am writing here f inverse of x. So inverse symbol, it is -1 we are writing here, means I am reversing the function. So it is possible to reverse a function. To reverse a function means first there should satisfy the 1 1 and onto. If a function satisfy both 1 1 and onto, we can reverse the function. We can totally reverse the function. The f inverse of x will become here. So y by 2 is there. No, I am going to write in the form of x. So x by 2 it becomes. So f inverse of x equals to x by 2. It means if you want to go from domain to codomain, you have to double. If you want to come from a codomain to domain, you have to divide. So both are possible here. So in function is 2x. Invertible function here, invertible function is x by 2, means we have to divide by 2. If you want to go from domain to codomain, we have doubled it. So that function satisfies the 1 1 and onto. So if it is satisfy 1 1 and 1 1 and onto, means there is a route to come a reverse also. So the reverse route is, the reverse function is x by 2. This x by 2 is nothing but an invertible function. So invertible function means we can reverse the function, means a function which can go from domain to codomain. No, so that same function which can be reversible. If you say if you can be reverse the function, then it is invertible function. To say f is invertible function, first it should satisfy 1 1 and onto here. So same way for this fourth question also, we have to check 1 1 and onto. Okay, if it satisfy both 1 1 and onto, then we can say it is a invertible function. It means we can reverse that function. Whatever the given function f of x equals to 4x plus 3 is there, no, we can reverse that function. I hope you understood the invertible function. Now let us start to solve the problem. So same way 1 1, how we are going to how we solved in previous 3 questions, in same way we are going to solve 1 1 and onto without any change, without any new concept here. So same pattern will be for 1 1 onto, same pattern will follow, but there will be domain and function values are different, but the procedure will be same. So let's start with the 1 1. Okay, solution 1 1. So let's start the 1 1 here. So 1 1 means first we have to consider. So I'm going to consider, let us consider same thing, same lines I am writing. Let us consider x1 comma x2 belongs to natural number. So domain is n. So I'm writing here domain. It is a domain. Domain is a natural number. So from that natural numbers I have considered x1 and x2. So suppose next I am going to equal this. Suppose f of x1 equals to f of x2. I hope you understood this part, because in previous 3 questions I have explained clearly. If you have not understood this part, please watch those previous 3 questions, then only you can understand this problem easily. If you watch those 3 problems and understand those 3 problems, then to solve this problem is a very easy. Okay, suppose f of x1 equals to f of x2. F of x1 means our question is here 4x plus 3, no, 4x plus 3. So f of x1 means here we can write 4x1 plus 3 equals to f of x2, means in the place of x we have to substitute x2. That's it, 4x2 plus 3. 4x2 plus 3. Now I am going to cancel out which are same in LHS and RHS. Here in LHS plus 3 is there, in RHS plus 3 is there. So I have cancelled here. So now it becomes 4x1 equals to 4x2. Now again I am going to cancel out which are equal. So here in left hand side there is 4 multiplied to x1 and the same 4 multiplied to x2. So I have cancelled out these 2 4. Now we got x1 equals to x2. Therefore we can conclude f is 1 1. F is 1 1 function. We can conclude that f is a 1 1 function. So we have solved this 1 1 here. So now we have to check for onto. Yeah, let's check for onto. Same way we are going to check for onto. So onto means we have to consider y value. So let us consider So let us consider y belongs to capital Y, because codomain is a capital Y here. So I am writing it is codomain. So here I have considered capital Y because the given capital Y is a codomain part here. So in previous questions the domain and codomain are different. So I have considered different. So here codomain is a Y. So I am considering this Y belongs to capital Y. Okay. So next this Y we have to make sure equal to f of x, because if I have already explained y equals to f of x, why we are going to write y equals to f of x in onto, because we have to find a x value here. For x image is f of x and the same point we have considered y, so both are equal now. So y equals to f of x means 4x plus 3. In question we have f of x means 4x plus 3. Our main intention is to find x value. So here I am not changing this 4x value, I am just removing this plus 3 left side, it becomes y minus 3. Then therefore x equals to, now this 4 is multiplied to x, no? So if we remove this 4 to left side, it becomes division. So y minus 3 divided by 4. So now I got x equals to, y minus 3. If you observe clearly here, so y is nothing but a natural number. Okay, y is nothing but a natural number, and y should satisfy this 4x plus 3 condition. Whatever the values will get out of 4x plus 3, those values are contained in this capital Y. We already found out the capital Y contains 7, 11, 15, so on. Okay, so if you observe here, y contains 7, 11, 15, so on, those type of values it contains, now y contains 7, 11, 15. So simply just check for the sake of clarity, for the sake of verification, just put 7. So y equals to 7. If you put y equals to 7, it becomes 7 minus 3 divided by 4. Okay, in the place of y I have substituted 7 just to verify it is the x value is in domain or not. Okay, so 7 minus 3 divided by 4, 7 minus 3 is nothing but a 4, 4 divided by 4 is nothing but a 1. So 1 is a natural number. So we are going to get a natural number here. So it means whatever the y value you put, so there are only limited y values which are came from the 4x plus 3 itself. So if you substitute those y values, definitely this x going to be in natural numbers. So x belongs to natural numbers. Actually if you see this y minus 3 divided by 4, it doesn't look like belongs to natural number, because it is like a fraction. Y by 3 divided by 4 is there, no, it is looking like a fraction. So actually fraction will be not present in natural numbers. Okay, but here this fraction will be present in natural numbers. Why? Because this y is restricted. Here y contains only 7, 11, 15, those values. So these values are came from this 4x plus 3 itself. So in question they have given, so y values are nothing but after solving 4x plus 3, whatever the values we got, those values are present in y they have mentioned. So if you substitute again those values, definitely we are going to get a x value, that to natural numbers. So y minus 3 belongs to, y minus 3 divided by 4 belongs to n. So this is in domain. So now from y we have considered in codomain and we got a x which is in domain, we have to write this in a sentence. So I have explained in previous questions only, this sentence is important, we have to write here. So the sentence is easy actually. So the sentence is, for all, so we have to use the word for all y belongs to capital Y, this is codomain, there exist x, we got a x is looking like y minus 3 divided by 4, which is also belongs to domain n, such that f of x in the place of x we got now y minus 3 divided by 4, f of x equals to y. So if we substitute in the place of x y minus 3 divided by 4, we are going to get a y value here. Therefore we can conclude f is onto function. F is onto function. So if f is onto means we can say f is 1 1 and f is onto, hence extra we have to write here f is invertible function, because the question they have asked to show that f is invertible. So here f is invertible function. Here f is invertible function. Hope you understood up to here. And also they have asked to find the inverse of f. it is also easy here. Inverse we have to find, no? After showing the f is invertible function, what will be the inverse of f? So here see, just observe here. Here x value, we know x value is nothing but y minus 3 divided by 4. Y minus 3 divided by 4. So f of x equals to y, no? F of x equals to y. What will be the x here? X is nothing but, if you remove this f to right side, it becomes f inverse. So f inverse of y, it becomes, so x value will become f inverse of y. If you substitute x in the place of x, f inverse of y, so it becomes f inverse of y equals to y minus 3 by 4. So this is inverse. We write inverse is f inverse of y equals to y minus 3 by 4, or in the form of x also you can mention, or f inverse of x equals to x minus 3 by 4. Whatever the value you can write, in the form of y we can mention, in the form of x also we can mention. The invertible function will looks like this, looks like y minus 3 divided by 4. I hope you understood. From where it is came means, we have found already, no, x value. So this x value is nothing but a invertible function. This x value, if you x value, if this f becomes a 1 1 and onto function, then this x part will become a invertible function. This x part will become a inverse of that function. So I have mentioned this x means that x is nothing but a f inverse of y, no? So f inverse of y equals to y minus 3 by 4. If you substitute a y value, you are going to get a x value here. So reverse, so we are going to get a reverse value. So first f of x equals to 4x plus 3 means, if you substitute a x value, it is if we substitute x value from a domain, you are going to get a value in codomain. So now invertible, what the invertible function do means, if you substitute a codomain value in that function, you are going to get a domain value. So it is moving from a reverse order. If a function moves from, if something relation moves from a domain to codomain means, we name that as a function, no? So in reverse order, same function moves from reverse, from codomain to domain means, then it is a invertible function. It is only possible when the given f is 1 1 and onto, that we have to check first. So whenever they ask show that f is invertible, first we have to show f is 1 1 and f is onto. Whenever they ask to show f is bijective, first we have to show f is 1 1 and f is onto. The same method. So if for 4 problems we have solved the 1 1, same. For 4 problems we have solved the onto, same method, same structure, all same. So domain, codomain, function will be changed for different question. Okay, so method will be the same. So if you understand this concept, if you understand the inner meaning, and in the understanding the concept in with clarity, then it is going to help to solve a KCT problems. So I hope you all understood these 4 problems. If you not understood anything or any concept here, please comment in comment section, so that I can know what the topic you are not understanding, and I can clarify in next video, or I will clarify in a comment section. Okay, I hope you all understood. So next upcoming videos, I am going to explain the KCT problems, that to topic wise, from this chapter, relation and function. Okay, so let us all meet in next video. Up to then, subscribe my channel, and also like my videos, so that I get a motivation to do more videos, and also share to others, your friends and family. Okay, bye.